Dear my student, let us proceed. We are now under the third mode of vibration. Let us have a look here on how a third mode of vibration appear to be. Instead of, let us assume, let us draw this one here. Node to node, this is the first mode of vibration. Another node, the second one. When you add another node, this is the third one. Therefore, the third mode of vibrations appear to look like this way. This is only if much energy is applied to the string. Therefore, this is, remember, the length of the string remain to be the same, but what is changed is only the shape of the string. That means the modes. Now, if the shape changes, that means the wavelength of the string changes. Now let us look here. What is the relationship between the length of the string and the wavelength under the third mode? At this point, this is a half, this is a half, this is a half. 1.5, that means 3/2. Therefore, the length and the wavelength, length is equal to 3/2 of the what? Of the wavelength. Thus, L equals to 3/2 of lambda. Now what is lambda? Lambda is nothing but 2L/3. This is how lambda and L relates. Now after here, you'll be asked to calculate the second overturns. Second overturn here, because the second overturn is occurred under the frequency. The frequency here, F, is V/lambda. But when lambda is equal to 2L/3, it will be no longer frequency, but it will be the second overturn, F2 dash, which will now be equals to V/lambda. Lambda is 2L/3. Therefore, this is the same as saying 3V/2L. Therefore, the second overturn is given by 3V/2L. After there, second overturns, we have said F2 bar dash is equal to 3V/2L. This is the same, remember V is tension L over, this is the same as saying 3/2L under root of tension L over M, because V is equal to tension L over M under root. Therefore, what is this? This is the second overturns. The second overturns. Therefore, what we need here, we want to know under the second overturns is the same as which harmonic? Is the third harmonic or fourth harmonic or whatever. Therefore, we are going to look at the nth harmonic. Nth harmonic is calculated by taking overturn over fundamental frequency. This is how we can know what is the harmonics. What is the harmonics value here? Now, what is the overturns? Overturns is this one here, 3V/2L. You divide by fundamental frequency, which was V/2L. Therefore, this is like to say 3V/2L times 2L over V. Therefore, the third mode is the same as the third harmonic. The third mode is the same as the third harmonic. What can we conclude? The second overturn is the same as the third mode. Is the same as the third harmonic. Is the same as 3V/2L. Is the same as 3/2L under root of V of 2L. Therefore, the second overturn and the said harmonic is the same. The second overturn and the said harmonic is the same. Now, we want to know the relationship between the second overturns, which is the same as the said harmonic with fundamental frequency. We know that the second overturn, which is the same as the said harmonic, is the same as this one is the same as 3V over 2L. This is equal to 3V of 2L. Call this one as equation 1. But also we know that the fundamental frequency, which is the same as first harmonic, is equal to V of 2L. Call it, this is equation number 2. Now divide the two equations. We're going to get F2 bar F3 over F0, which is the same as F1, is equal to 3V of 2L times 2L over V. This one cancel out. Therefore, F2 bar, which is the same as third harmonic, is equal to 3 times F0, which is the same as F1. Therefore, if at all you have been asked to calculate the second overturn, which is the same as the said harmonic, and you have the fundamental frequency, which is the same as you have the first harmonic, you just take that value times 3. Times what? 3. You're going to get either the second overturn or the third harmonic, because these two are the same. Therefore, this is how the two relates. Therefore, I'm just leaving you the task of going to derive or to see how the relationship under the first mode. Look the relationship under the first what? Under the first mode. Under the first mode, we can have this diagram here. This is the diagram. Node for the said, and this I think the first mode. This one here. That we have the diagram like this. Have the diagram like this for the first mode. Now I need you to find out the said overturn, but also I need you to find out the first harmonic, but also I want you to find out what is the relationship between the said overturn, which is the same as first harmonic, against the fundamental frequency, which is the same as the first harmonic. I think now that is very simple to you. Now after there, let us look the following. After there, let us look the following. We have seen that for the harmonics, we have been given that we have generally we have the general formula as follows. Generally, harmonics Fn is the same as n times F0. This is the general formula, where n is the vibration, the number of vibration mode. For example, if n is the first mode, that means 1, it will be equals to n, which is 1. 1 times F0 is equal to F0. Therefore, the first harmonic is the same as fundamental frequency. If n is 2, let us now 2 equals to 2 here, F0. Therefore, the second harmonic is the same as twice of the fundamental frequency. Therefore, this formula is correct, that if at all the relationship between the harmonics and the fundamental frequency are given by this symbol, by this formula, Fn equal to NF0. But what about the overturns? The overturns are given by the formula which is saying Fn bar equals to n plus 1 times F naught. What does it mean? If n is 1, now F1 bar will be equals to n, which is 1 plus 1 times F naught. The first overturn is nothing but twice of fundamental frequency. I think this is what you have obtained in our calculations. Therefore, this is the general formula for calculating the overturns, but also this is the general formula for calculating the harmonics. This is for harmonics, this is for the overturns. Now, after there, want to conclude something here. After there, want to conclude something. Want to conclude that, let us recall the general formula, which is saying Fn is nothing but n for harmonics, n F naught. But this is the same as n, what is F naught? V over 2L. But what is V? This is the same as n of 2L under root of tension over mu. This is Fn, which is frequency. Now this is tell us what? Frequency is direct proportion to under root of tension if other factors remain constant. That means if we remove proportionality sign, we'll end up getting F1 of under root of tension 1 equals to F2 of under root of tension 2. This formula is very useful. You'll be asking some of the questions, they need you to use this formula. But what if mu is constant, tension is constant and mu is not constant? That means F is inversely proportional to under root of what? Mu. If this is the case, we're going to get F1 under root of mu 1 equals to F2 under root of mu 2. But what if mu and t are constant but L is not constant? What are we going to get? We're going to get F1 is inversely proportional to what? To L. Hence, F1 L1 is nothing but F2 L2 through calculation. I hope that is well understood. We can end up there, so that after a few minutes we're going to look on numerical examples under that and this part.